Okay, the last thing we're going to look at here in section 1.4 is the concept of simplifying complex fractions. All right, so a complex fraction is basically one that consists of smaller fractions being combined in some way, shape, or form, addition, subtraction, occurring both in the numerator and the denominator. So how do we simplify these complex fractions? Well, there are several ways of doing that, but what I like to do, and again, it seems to work well with most, is to come up with the LCD. Note the concept of LCD being presented again. That's important that you understand LCD. You need to come up with the LCD of all of the little denominators that are within or making up the larger complex fraction. So what would the LCD be here if you have an x, a y, and then an xy? Well, again, it's going to be the product of all of the prime factors of highest power. So with that being said, you know, x is just to the first here and here, so x is going to be part of the LCD. You have a y to the first and another y to the first understood, so that's also going to be a part of the LCD. So what I would do now at this point is multiply the top and the bottom of this large fraction by xy over xy. Am I allowed to do that? Yeah, why am I allowed to do that? Because this expression, xy over xy, is equivalent to 1. All right, you're always allowed to multiply any expression by another expression as long as that other expression is equivalent to 1. All right, now this is where it gets a little tricky. So really pay attention to what's going on here at this point. All right, so I'm going to look at just the numerator first and then the denominator second. All right, so in the numerator position, what I'm going to do is distribute the xy through this quantity, the quantity of 1 over x plus 1 over y. Note that this is not in, if we're just looking at the numerator of this complex fraction, this is not in the denominator position. This is understood to be in the numerator position. So when you distribute this through, let's see what happens. When you distribute this through, let's see what happens. Notice I'm trying to cover up what I don't want you to work on right now. So we're only looking at the numerator. So if you have xy times 1 over x, xy times 1 over x, the x's, in other words, you have this, xy times 1 over x. That's what you have. This is really understood to be over 1, okay? Do you see that the x's are going to be eliminated here? Do you see that these x's are going to be canceled out? And you're left with just y times 1, which is y. And then the same idea for the next one. xy times 1 over y. The y's are going to be eliminated, and so you just get plus x. This is your new numerator. Okay, now in the denominator position, well, same idea. You're going to distribute this xy through the quantity of 1 minus 1 over xy. All right? So what's 1 times xy? What's xy times 1? That's just xy. All right, finish with that part of it. All right, now well, the first thing is understand there's a negative here. So let's go ahead and put the minus, the negative right there next. Okay, so what's 1 over xy times xy? What's xy times 1 over xy? Wouldn't this give you, just this part right here, wouldn't this just give you xy over xy? It would. So that's just 1. And guess what? You're finished. Now again, that may take a couple times to look at to really understand that. And as always, as per usual, if you have any questions or concerns, please do not be shy. Please email me and ask the questions. All right, that's why I'm here. I'm here to just help you get through this material, okay? I'm available. All right, last one. Let's do this, one more of these. So LCD. That's our first move in this complex fraction. What's the LCD? Well, look at your little denominator. So we have an x, we have an x squared. Well, in this case, we have the prime factor of x, but this one is understood to be raised to the first, and this one is understood, or it's, I mean, it's blatant. It's raised to the second, right? So remember what the LCD is. If you have a repeating factor, it's the one of highest power. So in this case, the one of highest power is, of course, x squared. So x squared is the LCD of this whole thing, all right? Okay, so let's go through the motions one more time. Let's see if we can do this. Let's distribute on top. So what's x squared times 1? It's x squared. All right, what's now x squared times y over x? X squared times y over x. Let me write this down. Listen to what I'm saying. X squared times y over x. That's what's going on right here. Well, wouldn't this reduce? Wouldn't this become a 1 and this just be canceled out? You have 2 x's on top versus 1 x on the bottom. So this would give you xy. So again, y over x times x squared is just xy. Okay? In the denominator, you have 1 times x squared, that's x squared. And then you have, what? X squared times this, negative y squared over x squared. Here, again, folks, you have an x squared on top. This is understood, even though, you know, it looks like it is in the denominator of this fraction. When you look at it with respect to the entire complex fraction, you only look at the numerator first, and then the denominator second. That's what I would suggest. So just pretend like this is its own unique expression in which you're multiplying an x squared through, okay? So x squared times y squared over x squared, these two are going to cancel now. And you're left with just minus y squared. Now, note in this particular case, and this could be possible in some problems, you are actually able to factor both the numerator and the denominator. So pay attention to that. Make a note to yourself. Once you get to this point, check to see if it's possible to factor it. If it is, then do so. And let me explain what I just did. On the top, I factored out the LCD of x. Okay, on the bottom, you need to recognize that this is a difference of 2 squares. So this is what the product would be of a difference of 2 squares based on this. Y, well, square root of x, the square root of x squared is x. Square root of y squared is y. Then you alternate the signs. At this point, does anything repeat? Does anything repeat here on the top and on the bottom? Well, I think it does. You have an x plus y and x plus y. Therefore, your final answer is this. X all over x minus y. So, what was once this nasty looking thing is now this. All right? All right, that completes section 1.4. Again, I can't emphasize enough. If you are struggling with this, if this is not coming to you, please reach out and I'll do the best I can to assist you. Also, make sure to attend the SI sessions. All right, check Isidore for more information on SI with Erica. Thanks.